Okay, so now we shall explain what do you mean by the partition of a sample space. Partition of a sample space. So what do you mean by partition of a sample space? So suppose a set of events we have, a set of events like E1, E2, E3 till En. Suppose we have n number of events. So that will represent, a set of events will represent a partition of a sample space, a partition of a sample space S if the first condition is the events should be pairwise disjoint. The event should be pairwise disjoint. Means what? It means EI intersection EJ should be equal to phi for any, for I not equal to j, where I comma j can be 1, 2, 3 till n. So out of these n number of events, if we take the intersection of any two of the events, then it should be equal to phi. Then we will say that the events are pairwise disjoint. And the next thing is the events should be exhaustive. The event should be exhaustive. It means what? It means that E1 intersection, no, sorry. E1 union E2 union E3 union till En. So the union of all these events should be equal to S. And the next condition is the probability of any of the event that should be greater than 0 for all I equals to 1, 2, 3 till n. It means what? It means every event, each and every event out of these n events should have non-zero probability, should have uh, positive probability. I mean, should have positive probability. Okay. So based on this, we have one theorem which is called as theorem of total probability. Theorem of total probability. Theorem of total probability. So now we shall state the theorem. Let suppose we have all, let's suppose we have n number of events, E1, E2, E3 till En. So we have the set of events such that this should be a partition of this sample space. So let this represent, let this be a partition of a sample space, of a sample space S. And suppose all events have non-zero probabilities, It means It means P of EI that should be greater than 0 for all values of I equals to 1, 2, 3 till n. Okay. Then suppose let A be any event. Let A be any event which is associated with that sample space S. Associated with the sample space S. Then the probability of occurrence of that event A can be written as probability of occurrence of the event E1 times probability of the event A given that E1 has happened plus the probability of the event E2 times the probability of the event A given that E2 has happened, plus like this we can go on till the probability of the event En times the probability of the event A such that the event En has happened. Okay, so this we can write it in the summation form. Therefore, probability of the event A that will be equal to summation of j goes from 1 to n, probability of the event Ej times the probability of the event A given Ej has happened. So we can diagrammatically represent it like suppose we have a sample space S. It means that S is a set of the sample space. Then let's say A is any event in that sample space. So A should be obviously a subset of S. Then suppose we have lots of partitions. Suppose we have the partition, suppose E1. Then we have one partition, suppose E2. And we have another partition that is E3. We have another partition that is E4. Then we have suppose another partition which is E5, and this remaining partition is suppose E6. So suppose we have 6 partitions of this sample space. Okay. So then we can write the probability of the happening of this event A as like this. So we can understand this. So this is called as what? This is called the theorem of total probability. Theorem of total probability. Okay. Then we can understand this by one example. Suppose we have a person who has to complete a job, has to complete some work. A person has to complete some work. And the work is a construction job. Work is construction job. Then um, let's say we have um, 2 events where there can be a strike or if there is and there cannot be a strike. So there are 2 possibilities. 2 possibilities are there. 2 possibilities. One is that there can be a strike, and one is that there is no strike. So if there can be a So if there is a strike, means if there is a strike, then the work may be completed or the work may not be completed. Okay, so if there is a strike, then the work can be completed or the work may not work uh, can be not completed also. And if there is no strike, then also the work can be completed on time. I'm saying can be completed on time, and it may not be completed on time. And if there is no strike, then also it can be completed. It may be completed on time, and it may not be completed on time. So let's say A is the event where job is completed on time. And the job is completed on time. And let's say B is the event where there will be a strike. There will be a strike. So here we have to find the probability that the construction job will be completed on time. So we have to find the probability of A. Okay. So here it is given that the probability that there will be a strike, the probability of happening of the event B, that is 0.65. So therefore I can say that probability of B complement means there is no strike. So that would be 1 minus probability of B, that is 1 minus 0.65. So it is 0.35. Then, then it is told that the probability that the construction job is completed on time, construction job is completed, the probability that the job is completed on time, given that there is a strike. It means what? It means it is given the probability of the event A given that B has happened. So that is given as 0.32. Okay. And it is also given that the probability that the job is completed on time given that there is no strike. There is no strike. That is 0.80. So it means what? It is given that so the probability of happening of the event A given has B, given that B has not happened, it means there is no strike. That is 0.80. So now, so here we can see, so the events B and B dash are obviously a partition, obviously a partition of the sample space S. Sample space S. Where the sample space here in this case is what? The sample space is that there is no strike or there can be strike. There is a strike. So only two events. So it means that, so therefore, according to the theorem of total probability, under the theorem of total probability, we can say that the probability of happening of the event A, that is equals to the probability of happening of the event B, given that B times the probability of happening of the event A given that B has happened, plus the probability of happening of the event B dash times the probability of the event A given that B has not happened. So that will be equal to, so now probability of B, that is 0.65 times the P of A given B, that is 0.32, plus it is probability of B complement, that is 0.35 times the probability of P of A given B complement, that is 0.80. So if we solve it, then we will get, this will become 0.208, plus this will be 0.5 is a 40. Yeah, so it will be 0.28. So if we add that, then we will get 0.488. So this is the final answer. Thank you.